Section 2.1, Frequency Distributions for Organizing and Summarizing Data. The key concept of this section is that when working with large data sets, a frequency distribution or frequency table is often helpful in organizing and summarizing data. A frequency distribution helps us to understand the nature of the distribution of a data set. Now, a frequency distribution, or also known as frequency table, shows how data are partitioned among several categories, also known as classes, by listing the categories along with the frequency of data values in each of them. Now here we see a table that represents the daily commute times in Los Angeles. So let's go ahead and explore this a little more. Above you will find the daily commute times in minutes in Los Angeles. And to the right is an example using commute times in Los Angeles using a frequency distribution summarizing those times. Now, the frequency for a particular class is the number of individuals that fall into that class. So, for example, here's the frequency, therefore that's the frequency. And it says, for example, in the first class, the table has a frequency of 6, which is 6 there. So 6 of the commute times are between 0 and 14 minutes inclusive, meaning that it has to be in between 0 and 14. And there's the class. Now, if you examine the list of frequencies, you can see that the commute times are distributed with the most of the times being at the lower end. So here 18 is between 15 and 29, 14 is between 30 and 44, and the rest of them you can see become a lot smaller as far as the frequencies are concerned. Okay, now we do want to talk about this particular frequency distribution table. The lower class limits are the smallest numbers that can belong to each of the different classes. So if you take a look at the table above, it has the lower class limits of 0, 15, 30, 45, 60, 75, and 90. Now the upper class limits are the largest numbers that can belong to each of the different classes. So the table above has upper class limits of 14, 29, 44, 59, 74, 89, and 104. Okay, so next we want to take a look at class boundaries. Okay, so we're going to take a look at the figure below and to the right and discuss class boundaries. Okay, so the class boundaries are the numbers used to separate the classes, but without the gaps created by class limits. This figure below, over here to your left, shows the gaps created by the class limits from the above table. Now, in the figure, okay, we see that the values of 14.5, 29.5, 44.5, 59.5, 74.5, and 89.5. They are in the centers of those gaps. So here's your class limit from 0 to 14. And then you have the next class that starts at 15 to 29. Well, this number 14.5 is in the middle there. Same thing here. We go from 15 to 29, and then from 30 to 44, and then we have 29.5 that's in the middle. That's why they're saying those are the centers and the gaps. Now, these are called the class boundaries. Now, following the pattern of those class boundaries, we see that the lowest class boundary is going to be negative 0.5. So down here we have one at the beginning. Even though that it's not in the table, we need to make sure that we know that that represents the lowest class boundary. And then the highest class boundary, okay, is 104.5, and therefore you can see that one. So therefore, the complete list of the class boundaries are the following: negative 0.5, 14.5, 29.5, 44.5, 59.5, 74.5, 89.5, and 104.5. Okay, so let's discuss how they are getting the boundary points, or the class boundaries. So if you take a look at the upper class limit for the first class, it is 14. The lower class limit of the second class is 15. If we add the upper class and the lower class limit, 14 plus 15, and then divide that by 2, well, that's going to give us the 14.5 here. Okay, if I want to find the class boundary here, again, I'm looking at the upper class limit now of the second class, which is 29. And then I'm adding the lower class limit of the third class, which is 30. And then divide that by 2. And then we get 29.5. Okay? And now, if you notice, is there a pattern between these two numbers? So we're going to go ahead and do the next one, which is 44 and 45. So I want you to think about if there's a pattern there. So if we take 44, add 45, and then divide that by 2, and we get 44.5. Now let's take 44.5, and then we're going to subtract 29.5. That gives us 15. Okay. Now, what's the difference between 29.5 and 14.5? So 29.5 minus 14.5. Well, that gives us 15, right? So we can see here that if we added 15 to 44.5, we would get 59.5. If we add 15 to 59.5, we would get 74.5. Add 15 to 74.5, we get 89.5. And if we add 15 to 89.5, then we would get 104.5. Now, how do we get negative 0.5? Well, we're going to take 14.5 and then subtract 15. And that gives us negative 0.5. So that's how you get the first class boundary, which is the lowest class boundary, and how you end up with the last class boundary. So again, to find the class boundaries, you take the upper class limit, add the lower class limit to the next class, and divide it by 2. Next, we're going to talk about midpoints, class midpoints. Now the values in the class midpoint, middle of the class, or these are the values in the middle of the classes. So how do we find those? Well, now we're going to take the lower class limit and the upper class limit. So let's go ahead and do that. So we're going to take 0, which is the lower class limit, the value of the lower class. So we're going to say 0. Put this on screen. Okay, so you have 0 plus 14, and then divide that by 2. Well, here we get 7. That's in the middle of the class. If you take 15 and add 29, divide that by 2, 44 divided by 2 gives us 22. Okay? Now remember, the differences between these class boundaries were 15. So what do you think the differences are going to be between the class midpoints? Well, if we add 15 to the 22, we're going to get 37. If we add 15 to the 37, we get 52. So those are the class midpoints. So remember that each class midpoint can be found by adding the lower class limit to the upper class limit and then dividing the sum by 2. Now the class width. The class width is the difference between two consecutive lower class limits, or two consecutive lower class boundaries, and a frequency distribution. Now the table above uses a class width of 15, and we've noticed that. 15 came up as a difference between the class boundaries. We also saw that 15 was a difference between the class midpoints. So the first two lower class limits are 0 and 15. So if you look at the lower class limit of the first class, which is 0, and then the lower class limit for the second class is 15, well, 15 minus 0 is 15, and therefore that gives you the class width. Now, caution, okay? The definitions of class width and class boundaries are a bit tricky. So be careful to avoid the easy mistake of making the class width the difference between the lower class limit and the upper class limit. Okay? Now, also, make note that the class width is 15, not 14. And you can simplify the process by finding class boundaries by understanding that they basically split the difference between the end of one class and the beginning of the next class.